Okay, everybody. So here, tutors, this right here is the activity that we're doing for 1.16 solutions to standard form equation. Alright, so the idea behind this is to match up basically four things together, right? We're going to have a word problem. Okay, so we have S1, S2, S3, S4. There's a word problem. We have an equation that is in standard form, AX plus BY equals C, like E1, E3, E5, and E7. We have an equation that is in slope-intercept form. So slope-intercept form, M is the number that's in front of the X, and B is the constant that you're adding to the X term. So for example, E2, E4, E6, and E8. And down below we have a graph. And the graph can be fairly easily understood by, in this part, if you look at it, all of the graphs intersect the y-axis at different points. So all we would have to do is look up here at your slope-intercept form equation and look for b. And once you look for b, b is this number that you're adding to the x, or adding to the x term. So the graph that has a slope of 10, the graph that has a slope of 145 over 3, which is roughly about 50, right? Because 150 divided by 3 is 50. Graph that has a y-intercept of 100 divided by 3, which is roughly 33, and a graph that has a y-intercept of 10 over 3 right here, which is about 3.3, right? So going into there is a Desmos activity here. And let me see what that looks like here. Desmos, so it is Desmos, student.desmos.com, and it is join/join, and the code for it is 6WCMQ. V maybe. Alright, so if we plug that in, then we can go ahead and log in with your student account. Alright, and I've actually already done these, but the first thing that I ended up doing here is I separated all of the cards here. Alright, so first task was to just separate those that are, separate the graphs. Okay, put the graphs below here. Right, and it's just you have to manipulate this around a little bit, but let's go in here, and it says 1.16a matching activity, and so all of our standard form equations are right here. So we have to basically just look and just read through the paragraphs here in the word problems And these equations right here are just going to summarize those word problems for us in an equation so that we can set it up correctly. So County Fair is selling lemonade and bottled water. They sell each lemonade X for $5.50. So they just basically are looking up here and looking for 5.5. All right, and there it is. Okay, so this right here, $5.50. We continue to read on, and it says each bottle of water Y is $3. Okay, so $3, $5.50, and it says the total sales were found to be 145. There we go. And match that up. Okay. All right, and looks a little bit lower here. Move these down a little bit. Okay, so there is the first one. Now this one says we have a negative. And you notice all of these here are positives. Okay, so we have one, so we're going to have to look for some wording that is negative. So subtracting something from something, right? So if we look for it and we go down here, so you have 10 tokens to spend at the arcade, and you decide to play a particular game in an attempt to win back some tokens to play more games later. For every 2 tokens you spend, okay, so spending is not positive, spending is negative, right? You're taking away. So every 2 tokens that you spend, you seem to be winning exactly 3 tokens. All right, so you're doing pretty good. You're spending 2 tokens. You're going to be playing for a long time, right? Go to the Penny Arcade down in Manitou, and you're going to be playing for a while. Okay, so if you look at it, spending 2 tokens, 3 tokens is how many you're winning. So that's going to be positive 3, and it says you have 10 tokens to spend. All right, so negative 2x plus 3y equals 10, and we can go ahead and match that up right there. Move this over here. All right, so now I've set up, I went ahead and I set up those two. So we have a toss-up right here. Which one is it? And it's basically, for the most part, I'm just looking for patterns in numbers. So I got 2.5 each composition book. 2.5 costs $2.5, and each pencil costs 75 cents. So 2.5, 75 cents, $25 is how much we have. There we go. We match it up. Okay. All right. So I have my scenario, and then I have my standard form equation. So therefore, the last one, it has to be this one right here. Okay. All right, so I put those in, and now I'm down to just matching the graphs and the slope-intercept form equations with those graphs. Okay. So now this is probably I would say the most difficult part of it, but it's really not that difficult, because what you're going to look at is you're going to look at this y coefficient. Okay. Now the way I'm going to look at this right here is the y coefficient. I'm going to look at this, and I'm going to divide that y coefficient into the constant on the other side. Okay. So if I divide the y into the constant on the other side, which I'll eventually end up having to do if I bring this 2.5 over and then I divide by that on both terms, if I can find out what the y-intercept is, which would be the division of 25 divided by 0.75 here, okay, then I know that that's going to be my answer. Okay, so and that's going to be the plus whatever. That's going to be your b value, which is this right here. So remember, it's y equals m, that's your coefficient that's in front of x, and then mx plus b. B is your constant that you're adding to the x term. So if I can take 25 and divide it by 0.75, I'm going to get 33 1/3. Okay, so this one right here, 33 1/3, well, this looks like 100 divided by 3 is 33 1/3, because if I multiply 33 by 3, I get 99. So that's the closest fit right here, which would be this one. Okay, so I can match that up there. Okay, so now let me take this 3. That is my y coefficient. I'm going to take that 3 and I'm going to divide it into 10. Okay, so if I divide 3 by 10, there it is right there. That's the one. Okay, I don't really, I mean, yes, I do have to, I want to look at the other part of it to make sure that, you know, the slope is going to be correct. But if, you know, you're looking at these and all of the b values are all different. Okay, so that should lead you to believe that if you find the b value that corresponds to something, then that's going to be the one that works. All right, so this one right here, 5 into 50. 5 into 50 goes 10 times. So 50 divided by 5, 10. Okay, and last but not least here, this one right here, that's got to go there. Okay, there's only one left. Only slope-intercept form left. Okay, so now down to the last piece right here, I look for these right here. 100 divided by 3 is going to be 33, so I have to have a y-intercept that's at 33. Well, this one is just above 32, so that would make sense that this right here would be, the y-intercept would be roughly around 33. So 100 divided by 3 is 33. Okay, you can put that in there. All right, so this y-intercept is less than 4. So a y-intercept that's less than 4, 10 divided by 3 is 3.3. I would guess that this one would be right about there. That would be a reasonable estimate, because when I look at the others, they're all, you know, that one's greater than 4. Okay, and if this is greater than 4 and it's 10, this one right here matches up with this. Okay, and it would have to be that this one matches this one. Okay, all right, that's part A. Okay, so when you're explaining that to kids in the classes, just make sure that the first step is to separate them all. It doesn't matter how you separate them, what goes first, second, third, whatever. But you're going to separate all of the standard form equations, which are these right here. You're going to separate all of the slope-intercept form equations, okay, somewhere. You're going to put all of the word problems somewhere, and then you're going to put all of the graphs in a separate pile. Okay, then you can start matching them up as you go. Okay, just match up one set of 4 at a time. All right, so if I'm matching up, if I'm going to match up my standard form equations, which are these right here, I could match them up with my slope-intercept form equations right away. But when you do that with your slope-intercept form equations, match those up all first, and then start matching up your paragraphs, and then start matching up your graphs, which I think will be a lot more efficient. That's kind of a better plan of attack than not doing it. All right, so let's move on. Okay, so now we have to read, and this just says summative practice with writing equations. Okay, so summative practice with writing equations. Summative is a test, it's a big test. So we're getting close to the end of the unit test, the full big test. All right, so it says summative practice with writing equations. I read everything carefully. And when I read everything, it just says Manuel has $15 to spend on apps and music. Apps cost $2 each, and songs cost $1 each. Right? It's like we've been doing. we underline, okay, apps $2 each, songs $1 each, and there's our total. Okay, and is a plus sign. Okay, so if x, and we'll write this over on the side here, we could say x equals the number of apps purchased. So x equals apps, and it says y equals songs. Write a linear equation that represents the combination, so it's a combination, we're going to have some addition, combination of apps and songs Manuel can purchase. All right, so the apps correspond, apps connect with the $2 each, right? So apps are $2 each. So 2 times each app, apps are represented by x, so 2x. Okay, that and is a plus sign. And songs are $1 each. Okay, so I can either write it as 1y, and then it's going to end up equaling the total, which is $15, or get used to this way. Let's write it as y. Okay, so there it is. Circle it and you're good. All right, so this says rewrite this equation in a different form that will allow you to quickly identify the y-intercept. So what we're talking about is SIS, slope-intercept form. Okay? All right, so we're going to write it in slope-intercept form. You know, the more you get used to this, the more you're going to recognize, hey, if there's just an x term over here, all I got to do is move that x term over to the other side, and it's going to be in slope-intercept form. I already know right now from doing this, you know, practicing this over and over again, I already know that the y-intercept is going to be 15. All right, because it's not going to change when I subtract 2x to the other side. It's not going to change what the y-intercept is, because that constant is always going to be that constant right there. All right. Now, if this was a 2y, then I would have to divide that 15 by 2. Okay, but let's write it out here as 2x. Keep copying down the same thing. Okay, so in order to put this into slope-intercept form, remember our steps from last lesson. The first step is to subtract the x term, or subtract or do the opposite of whatever the x term is. All right. So I'm going to subtract. If the x term, if that was a negative 2x, I'd have to add it to both sides. Okay, because I'm trying to get rid of it on that left side. Minus 2x. Keep in mind, I am not putting that minus 2x right underneath the 15, and there's a specific reason. You guys know the reason. I talked to you about this last class period, or talked to all of everybody, but the reason is because I don't want to, you guys are tutors, you guys can explain this, but I don't want to think that I can add 15 and negative 2x. All right, so I'm just going to drop it down vertically. So 15 minus 2x. Okay, and that right there is slope-intercept form. We've switched the constant and the x term around. So technically we could say that y equals negative 2x plus 15. Okay. Okay, there it is. Rewrite this equation in a different form that will allow you to quickly identify the y-intercept. Slope-intercept form is that form. So that's all they were asking for, and that's the form that they asked for. There it is. Okay. I'm answering all questions. Okay, so it says Rohan bought a new memory card for his digital camera. If he takes only high-resolution photos, he can store 3,500 pictures. Okay. If he takes only low-resolution photos, he can store 7,000 pictures. All right. So this one right down here says x equals, and even when they state x equals, I would go ahead and write it out. I would write high res for x. Okay, and y equals low res. Okay. Now I need to write a linear equation to represent all the combinations. So combinations are going to be the, x plus y. So we have to figure out what that is going to be. So if we say that we take only high resolution, okay, so x is going to equal 3,500. If we take only high resolution, and high resolutions are represented by x, then wouldn't y be 0? Yes, because we could have an ordered pair as 3,500 comma 0. So if that's the case, we would say 3,500 plus 0 plus y equals okay, and we could say the other part of this right here is going to be, we would have no memory left, right? That's what would be our total memory, right? So that's all the memory that we could take. 3,500 plus y equals 0. We also have 0 plus 7,000 equals 0. Not 0 plus 7,000, sorry. That's going to be x plus 7,000. Okay, so our other one is, well, we're only going to take, it says low resolution photos. So if we only take low resolution photos, that means that we're not going to take any high resolution photos, so that's going to be 0, right? Alright, so in this case, we're going to have y equals 7,000. Alright, now, I like to look at this as a graph real quick though. Okay, so I got x and I have y, and it doesn't matter. It doesn't have to be a perfect graph or anything. I'm just going to say, all right, so y is 7,000, and x is 3,500. Okay, so if this is my picture of my graph, I know that b equals 7,000. My b value, my vertical intercept, is going to be 7,000. That's b. So I have to find out what m is. Alright? So m is going to be, and it just says write a linear equation. Doesn't matter what form it's in. Okay? And I'll write this as the x-intercept. That was off a little bit. Don't pay attention to that first part of it. And the y-intercept, 7,000. Okay. All right. Okay, so what is my slope? Well, let me show you this in a different color. Okay, so let me show you this in red. So I'm going to go down from here, and I'm going to go over. Okay, we're drawing triangles on this to see what the rise over the run is. Okay, so the rise, it's not rise, it's minus. To go from 7,000 down to 0, it's just negative 7,000. Okay, to go from 0, this is 0 right here, to 3,500. Okay, so I have 7,000 over 3,500. All right. Well, here's the thing. You know, with this, I got 2 zeros on the top, 2 zeros on the bottom. Now I start looking at numbers that are easier to deal with. 70 and 35. Well, I noticed, hey, you know what? 70 is divisible by 35. It's divisible. 35 goes into it twice. Okay, so my slope is going to be negative 2. Right? So if I have a slope of negative 2, then I could go ahead and write this out as a slope-intercept form. I have the slope and the y-intercept. So y equals negative 2m, right, x plus 7,000. All right, so now if I were to, now this right here is in slope-intercept form, another possible way of writing this is to take this negative 2, okay, you could add 2x to both sides. So you may see students doing this. If you add 2x to both sides, that's a plus there. Then you're going to get 2x plus y equals 7,000. Okay? All right, so either of those answers would work out. Would work out fine. Okay, and there's a lot of ways of figuring out a formula for that one. All right, this next one, it says, what is the slope of the line and what does it mean in the context? Well, we already know what the slope is. The slope, we already figured it out. It's right here. And we're just going to say m equals negative 2. All right? So what does it mean in the context of it? So that means when you take away 2 from the y-axis, take away 2 from 2 high resolution, no, actually 2 low resolution, we could say every decrease of 2 high res, no, sorry, low res, so X's. Every decrease of 2 low res pictures Rohan can increase one high res. So in other words, you have a camera and every high resolution pic you could do 2 low resolution pics, so you could do twice the low resolution pics as you could the high resolution. Okay. All right. Number 3, it says Javon is on vacation in New York City and wants to use a ride-sharing service. Every ride has a flat fee of $2.50 and an additional charge of, okay, so and is always plus, and an additional charge of 35 cents per mile. Okay, so we have our variables. C is the cost. That's the total cost of the ride, and M is the mile. So C equals total cost M equals miles. Okay. So there's a flat fee of $2.50. Flat fee just means that's another word for constant. Okay. This right here, it's per mile, so that's a rate. And a rate, as we know, is the slope. And we call that M in y equals mx plus b. Okay. All right. All right, so 35 cents per mile. So miles are represented by M. So we're going to write that out as 0.35 M. Our constant right here, right up here, is going to be $2.50. And that is what we've already talked about, we're going to add that together. So we've got a constant flat fee that we're going to be charged. Okay, so that's our expression for it. And what does that equal? It equals our total cost, which is C. All right? So linear function. Doesn't tell you that you have to use any specific sort. Now this is a little different than what we've been talking about. We've been talking about standard form equations. This is a slope-intercept form equation, so you have to kind of recognize it. How many numbers do we have in the slope-intercept form equation? We have 2. Okay, one right here, one right here. Okay, and then it's going to be set equal to. It's already going to be set equal to a certain, to that total cost. All right, that's because that's what we're trying to look for. So this is your typical input. You input something for M to get your cost. And that's it, straight up. The other types of equations, our standard form equations, are when we have, let's say 2 variables that, let's say, cost a certain amount, and then you have the certain amount to spend, right? And what is the combination of those variables that you can use to spend that to get exactly that amount? Okay. All right. How much can Javon expect to pay if he needs to travel 12 miles? Okay, well, what is miles? Miles are represented by M, right? So we're going to say M equals 12. So we take that same equation and we're going to take 0.35, and that's multiplied by M, 0.35 M plus 2.5, and I wrote the parentheses there because what I'm going to do right now is just erase M. Because look, right over here, that is what M equals. So M equals 12. Right? Okay, so when I solve this here, I can take out my calculator and I say, clear everything that's on there, and I say 0.35 times 12 times 12 equals 4.2 plus $2.50. So that's going to give me $6.70. right, so total cost is going to be $6.70. How much can Javon expect to pay if he needs to travel 12 miles? So Javon will pay $6.70. Okay. Lupe is the manager of a football team, and she has to plan a team dinner for Saturday night. She knows that one large pizza can feed 3 players. Okay, so this one's about pizza, right? Large pizza, 3 players. One sandwich tray can feed 4 players. So you got sandwich trays, feeds 4 players. And there are 72 players total on the team. Okay, so it says write a linear equation to represent the number of pizzas x. So x equals pizzas. Okay, y is going to equal sandwiches, sandwich trays. All right. X and Y, and the total number of players is 72. Okay, so the number of pizzas and the number of sandwich trays, remember that they're going to seat four players for one pizza, okay, per pizza, right? So if I have 2 pizzas, that will feed 8 players. 3 pizzas, 12 players. 4 pizzas, 16 players. Okay? So when we combine those two, we have to combine them, all right? And that word "and" it means plus. So plus. Did I do that wrong? Large pizza. Oh, that should be 3. Three players. Large pizza feeds 3 players. My fault. Okay, and one sandwich tray feeds 4 players. So four players per sandwich tray. Sandwich trays are represented by Y. Okay, so if I have one sandwich tray, which would be Y, multiply that by four players, I'm feeding 4 people. 2 sandwich trays, I'm going to feed 8 people. 3 sandwich trays, I'm going to be able to feed 12. Okay? So this all has to equal 72 people. Okay? All right, suppose the football players want to order exactly 16 pizzas. Okay? How many trays of sandwiches must Lupe buy to feed all of the players? All right, so 16 pizzas. So 16 pizzas, we're going to say x equals 16. All right, so if x equals 16, we're going to have to plug it in. We're at 3x, we write down our equation, plus 4y equals 72. Take that 16 and plug it right in here. Okay, so I'm going to erase that and write this out. Okay, and now I'm just going to break it down step by step. So we have 48. 3 times 16 is 48. 48 plus 4y equals 72. So in a 2-step equation is I'm isolating y. So I'm going to have to subtract 48 from both sides. Okay, that'll cancel out and I get 4y equals, well, this should be 24. 72 minus 48 is 24. And if 4 pizzas equals 24, what do I multiply 4 by to get 24? Well, it's 6, so y equals 6. So read back the question. It says, how many trays of sandwiches must Lupe buy to feed all of the football players. Okay, y is the trays right here, right? And we found y to be 6. So restate the question. Lupe must buy 6 trays of sandwiches. Okay. All right, moving on. All right, the size of the graduating class of Kyle's high school has been growing at a constant rate. Okay, so we're talking constant rate here. So they're telling you that it's a line. Because Kyle's older brother's class has 257 students when he graduated in 2015. Kyle is going to graduate in 2018, and his class is 329 students. Okay. All right, so we need to find, this one is perfectly set up. These are 2 points. Okay, we'll say X is the year. And Y would be the graduates. Okay, so we can set up a little table here. I like tables because it's easy to look at. All right, so we could say the year for Kyle's brother. Kyle's brother graduated in 2015, so 2015. Okay, and there were 257. Okay, so it keeps growing up, it's growing at a constant rate, and then 2000. Rewrite that. It's 2018. And the graduating class is 329. Okay. All right, so going from here to here and here to here, the rate M is our rate of change. All right, so I could write it as I start with this one right here, and I say 329 minus 257, which gives me a difference, right? Over 2018 minus 2015. I know that's 3 years on the bottom here, but what is 329 minus 257? 72. Okay. 72, if I can start recognizing it, 72, 24 goes into 72 3 times. Okay. If I didn't know that, just start putting that in your mind a little bit, start recognizing, seeing the patterns in the numbers. But if I didn't, I just take this and I say 72 divided by 3 gives me 24. All right. Rate of change of number of students per year. So 24 students per year. All right. So 24 students per year, it's an increase of 24 students per year. that's what it means. Doesn't ask me to do that, but I could just, if I left it at 24, that's fine. Okay. Now write a linear equation that models the school's graduating class size. So we're going to say y, this says y equals graduating class size. Yep, it's class size. So y equals class. It's exactly what we did. So we'll just call it class size. And x equals year, right? And that's what I wrote it as. Okay. All right. So write a linear function. Okay, so linear function. So any type of linear equation, I can write that as if I want to use point slope form, I'm going to go ahead and do this. I'm going to say y, or y minus y1 equals m times x minus x1. All right, we'll use this point. That's our x1 and y1, right? And we already figured out our slope, so our slope is going to go right here. So this is our y term right here. The 257 is our y term, so that's going to go right there for y1. And 2015 is going to be our x term. So that's going to go there. All right, so I can fill those in, so that y1 is going to be 257. The x1 is going to be 2015. And my m value right here is going to be 24. All right, so that right there is a linear function. We can recreate this linear function right here by plugging it in. We can move it over. We can move that minus 257. We can add it to both sides. We can distribute here, and then we can come up with a slope-intercept form of an equation. Okay, which would look like this. We would say y equals 24x minus, because I'm going to distribute here and here, 2015 times 24. Okay. And I'm going to add 257 to that. So y will equal 24x minus this amount right here. Now when you plug in the actual 2000, remember that your 2000, you could easily just say start at 15, 15 every year since 2000, you could say. But when you plug this in, you're going to get a negative y-intercept here. But this would be acceptable, minus or plus, I'll say minus 257. that wouldn't be as useful a graph for us if we use the 2000. If we use 2015, 2018, okay. But I would say that, just this equation. Once you get an equation, that's it. That's a point slope equation right there, and you're good. You're good to go. All right. So our last page here says the USDA suggests that a 10-year-old needs to consume about 2,000 calories. Okay. 10-year-old consumes 2,000 calories per day. Between the ages of 10 and 20, the number increases 100 calories per year. So 100 calories per year. Write an algebraic function rule that models the approximate caloric needs C of a girl in terms of her age A. So we're going to say A is going to equal age. We're going to say after 10 years old. Okay? So age after 10 years. At 10 years, okay, at 10 years it's 4,000 calories. So this right here, we could say that 2,000 calories is a constant, and we're going to say that that is our B value. That's y-intercept. Okay. All right. And our rate of change, our M, this right here is going to be M. That's our rate of change. Slope. Write an algebraic function. All right, so we got our slope and we have our y-intercept. Okay, so y equals mx plus b. Okay. Okay. Plug them in. So y-intercept, that goes there. Slope, that goes there. Okay. So let's erase them and plug them in. So M is 100. Okay, and remember the X is years after 10 years old. And B is 2,000. All right, so there's our algebraic function for that. All right, it says use your rule to determine about how many calories a 17-year-old, okay, a 17-year-old girl should consume per day. Okay, so we're going to say that, I'm going to erase these things right here. Okay, so we're going to say that X is going to equal, so remember 17 years old. Well, since we called it A up here, we'll say C was the caloric need. Okay, so C is our caloric need and A is our age after 10 years old. So age after 10 years old, well, A is going to equal 17 minus 10, which is 7. So 7 years after 10 years old. Okay? All right, so if A is 7, all right, so we have our equation, and actually this one should not be, this should be right there, it should be, call it C and A. Okay. Alright, so I plug it in. I say C equals 100 A plus 2000. Alright, well, A is 7, so we're going to plug in A right there. Right, so let me erase that. Now I'm going to write down 7. So we got 100 times 7. Got to do that first before we add. 700 plus 2000. So C equals 2700. 2700 what? Calories. Alright, so a 17-year-old girl should intake 2700 calories a day. Assuming that they're active and all that kind of stuff, but there it is. Okay, tutors, that's what you're looking for this.